The only topic we have left to cover is what happens when you shift conics around the coordinate plane. When we started with circles, we found out that if a circle was centered at the origin, it had this equation. If it was centered somewhere else, it had this equation, where the center was at h, k. For parabolas, if the vertex was at the origin, then it either had this equation or this equation, depending on how it opened. So if its vertex is somewhere else on the coordinate plane, the vertex changes to h, k. Let's see. X minus h squared is equal to 4p y minus k. So here are your equations of your parabolas shifted elsewhere. Ellipses, if they were centered at the origin, were x squared over a squared plus y squared over b squared equals 1, or the other way around depending on how it's elongated. So if it's centered somewhere else, the center moves to h, k. Nothing about how all the formulas with these conics changes. They all work the same, and I'm still going to give them to you on the test. You just have to know how to use them. So hyperbolas centered at the origin look like this, or the other way around if they opened up and down instead of left or right. So if we're going to shift them, the center just shifts to hk. Oops, not squared yet. B squared equals 1. So these are our shifted conics. Now what happens is the quantity that's inside the parentheses with the h will move the graph to the right. So anything that says x minus h moves the graph to the right h units. If instead it says x plus h, because h is negative, that'll shift the graph to the left. In the y parentheses, k will shift the graph either up or down. So if it says y minus k, this will move the graph down k units. But if it says y plus k, it'll move it up k units. Let's sketch a graph and find the foci of a shifted ellipse. And the shifted ellipse is x plus 1 squared over 4 plus y minus 2 squared over 9 equals 1. First of all, how do you determine how the graph of an ellipse is elongated? Is it elongated horizontally or is it elongated vertically? Which way it's elongated has to do with which variable has the bigger number under it. Since y has the bigger number under it, it's going to look like this. Okay, so now the first thing we want to determine is where the vertex is. The vertex is at -1, 2, because remember the vertex is at hk. So -1, 2 is going to be here. Then, since it's elongated vertically, we want to find out how many units above and below the center we need to go to plot our vertices. Well, since 9 is a squared, a is 3, so I need to go 1, 2, 3 units above and 1, 2, 3 units below. There are my vertices. Oh, I called that vertex, sorry. Center. My vertices, which are at h, k plus or minus a. So my vertices are at -1, 2 plus or minus 3. Well, does it look like my vertices are at -1, 5 and -1, -1? Absolutely, so we must have done it correctly. Then, if what's under y is a squared, then what's under x must be b squared, so b is 2, so I need to go 2 units to the right. and 2 units to the left in order to draw my ellipse. All right, there's my ellipse. The next thing they want me to find are where the foci are. Remember, the foci lie on the major axis. So for a parabola, ellipse, whichever conic we're talking about, which happens to be the ellipse, is elongated vertically, then the foci are going to be at h comma k plus or minus c, where c squared is equal to a squared minus b squared. Alright, so c squared is 9 minus 4, which is 5, so c is the square root of 5. So the foci must be at -1 comma 2 plus or minus the square root of 5. And if you want to make sure you did it correctly, if you actually turn square root of 5 into a decimal and add and subtract it from 2, you should get a number that's below where -1, 5 is, and one that's above where -1, -1 is. Make sure that it's inside the ellipse. Now let's talk about shifting a parabola. We want to find the vertex, focus, and directrix of the parabola x squared minus 4x is equal to 8y minus 28, and we want to sketch a graph. Well, the first thing I'm going to try to figure out is this a parabola that opens up or down, or left or right? Since x is the variable that is squared, it opens up or down. So I want the equation to say this. That way it's easy to extrapolate the information that I need from it and find p. But right now it's not written in that form. So in order to write it in that form, we're going to have to go back to good old completing the square. Now, this is how it works. We need the left-hand side to be in factored form, so we're going to complete the square on the left-hand side. So remember, anytime you add something to one side of an equation, you'll keep it balanced by adding something to the other side. The number we're going to add here is 4. That's what completes the square. So the left-hand side factors into x minus 2 squared, and then the right-hand side is 8y minus 24. But we have to do one additional thing. We have to take out 4p. In other words, we have to factor the right-hand side so the coefficient in front of y is 1. Well, that's easy. All I have to do is factor out an 8. So now I know that this is a parabola that opens up because p is positive. I can find the vertex. The vertex is at hk, so it's at 2, 3. In order to find the focus and the directrix, I need to find p, so 4p is equal to 8, so p is equal to 2. The focus is at h comma k plus p, so in this case it's at 2 comma 3 plus 2 is 5. The directrix is going to be at y equals k minus p, so it's at y equals 3, minus 2, so it's at y equals 1. And the graph, let's see, it's 2, 1, 2, 3, it's going to look like this. And it's really all you need to know about the parabola. Now let's do a shifted hyperbola. We want to find the center, vertices, foci, and asymptotes of this particular hyperbola. In order to do this, we need to put the hyperbola in our standard form, and right now it's in general form. Remember, the reason I know it's a hyperbola, other than the fact that I told you, is because x squared and y squared have opposite signs. So when one of them's positive and one of them's negative, it must be hyperbola. Okay, in order to do this, we're going to have to go through that process of completing the square. Always put the x's together first. Always start with a plus sign between the x parentheses and the y parentheses. It may change to a negative later, but always start with a positive. Then in the y parentheses is negative 16y squared minus 32y plus blank, and that's going to equal 16 plus blank plus blank. In order to complete the square, you have to have a leading coefficient of 1. So, whatever coefficient is in front of the square term, factor it out. So 9 gets factored out of the first one. X squared minus 8x plus blank. Negative 16 gets factored out of the second parentheses. Watch your signs. Y squared plus 2y plus blank. Remember, the third term stays positive even though you factored out a negative 16, because when you complete the square, the last term is a perfect square, and perfect squares are always positive. Now we're ready to fill in the blanks. The first blank is 8 divided by 2 is 4, 4 squared is 16. The next one, 2 divided by 2 is 1, 1 squared is 1. But those aren't the terms that go on the right-hand side. You have to factor in the fact that you factored out a number. That was a lot of F words. All right, so 9 times 16 is 144, and negative 16 times 1 is negative 16. Notice on the right-hand side, those 16s will cancel. All right, now let's go back and do this. This first parentheses is x minus 4 squared minus 16, y plus 1 squared is going to equal 144. And the last step to put it in standard form is to divide everything by 144 and reduce those fractions. So I get x minus 4 squared over 16 minus y plus 1 squared over 9 equals 1. And there's my equation. Since I've run out of space on this page, I'm going to go to the next page in order to find the remaining information. So, the equation we found was x minus 4 squared over 16 minus y plus 1 squared over 9 equals 1. So now let's go do the remainder of the problem, which is to find the center, vertices, foci, and the slopes of the asymptotes, because I don't care about the equations of the asymptotes. The center of this hyperbola is going to be at 4, negative 1. 1, 2, 3, 4, here. I know that this hyperbola opens left and right because of the x squared coming first. So in order to graph it, this is, sorry, something weird just happened on my iPad. Let's try this again. I know that this is a squared here, so a must be 4. So there must be some point 1, 2, 3, 4 units to the right and one that's 4 units to the left. B squared is 9, so there must be a point that's 3 units above and one that's 3 units below. And the reason we graph that is because it helps us find our asymptotes. The asymptotes of this hyperbola are going to be the diagonals of this box. Instead of dashes, they kind of look like dots, don't they? So I know that the hyperbola looks like this. The other side's going to be a little bit harder because I'm running off my screen, but that's what it looks like. The vertices are going to be at h plus or minus a, comma k. So they're going to be at 4 plus or minus 4, comma negative 1. Well, does it look like my vertices are at 8, negative 1 and 0, negative 1? No, because I graphed one of them wrong. Gotta say no, because I graphed one of them wrong. I didn't count 4 spaces, did I? Should have been here, right? And then I would have had my nice hyperbola. Yes, now it's correct. The asymptotes, next thing that I can do without finding C yet, are going to be at plus or minus b over a. So the asymptotes, the slopes, must be plus or minus 3 over 4. And if you kind of look at the asymptotes, they kind of appear as if they're probably 3 over 4. Last but not least, let's find the foci. Well, in order to find the foci, I got to find C. For hyperbola, a squared plus b squared equals c squared. Or you could use the b squared is equal to c squared minus a squared. It's the same exact formula. Either way that you do it, you find out that c squared is 25, so c is 5. The foci are at h plus or minus c, comma k. So the foci must be at 4 plus or minus 5, comma negative 1. So they should be at 9, negative 1, and they should be at negative 1, negative 1. A degenerate conic is an equation which appears to be a conic, but when you go to put it in standard form, something doesn't quite work right. So let's look at this equation here, which appears to be hyperbola. The reason it appears to be hyperbola is because x squared and y squared have opposite sides. So we're going to go about the process of trying to determine what its standard equation is if I want to try to go and graph it. So I'm going to go complete the square. So I've got my 9x squared plus 18x plus blank. Remember to always start with plus, even though it may become minus. Negative y squared plus 6y plus blank equals 0 plus blank plus blank. I have to factor out the leading coefficient. Then I have to fill in the blanks. Let's see, 6 divided by 2 is 33 squared is 9. On the other side, I fill in the blanks with 9 and negative 9. And you should start to notice something's not quite going to work right, because the right-hand side, everything cancels and it's left with 0. Well, if everything's left with 0, how am I going to make this an equation that's equal to 1? Well, there's no way of doing it. What happens with a degenerate conic is you actually end up with a pair of intersecting lines. And I didn't do this part in class, but here's how it works. What I could do is I could add the y minus 3 squared to the other side. And then I could take the square root of each side. And problem is when you take the square root of 9, you get plus or minus 3. And then I could solve the equation for y, so I get y is equal to 3 plus or minus 3 x plus 1. So you end up with the equations y equals 3 plus 3x plus 3, which is actually y equals 3x plus 6. And the other equation you end up is y equals 3 minus 3x minus 3, which is y equals negative 3x. So these are your intersecting lines. They're not actually a hyperbola. And the way that you get it is that after you get your degenerate conic here that equals 0 instead of 1, you get your square terms on both sides, you square root everything, you end up with these two lines. It's called a degenerate conic.